Suppose you can take this summation root of n plus 1 minus root of n minus 1 by n. Is it positive term series? Yes, because root n plus 1 is always bigger than root of n minus 1 for every n. Therefore, root n plus 1 minus root n minus 1, this is always positive for every n. Therefore, this by n also positive. Therefore, your original sequence is positive. So whenever your original sequence is positive, you can deal with limit comparison tests, right? Already told you, whenever you are given a series like this, you can convert by taking the rationalization. So what you get? N plus 1 minus n minus 1 by n into root of n plus 1 plus root of n minus 1 by rationalization, right? This can be rewritten as summation n equals to 1 to infinity, n cancel, this is by 2 into n into root of n plus 1 plus root of n minus 1. Again, already told you, take the biggest power common. So here n common means take roots outside, is exactly what? Summation n equals to 1 to infinity, 2 by n into root n, 1 plus 1 by root n, 1 minus 1 by n, take common out. But this can be rewritten as summation n equals to 1 to infinity, 2 by 3 power 1 by 2, root of 1 plus 1 by n, plus root of 1 minus 1 by n, right? Now, what you do is, again, you can assume that this is my Bn. See, no need to take actually 2, right? It does not affect the constant cannot affect the convergence. So this is nothing but your Bn, right? Therefore, what is An by Bn? An by Bn is this cancel. What you get? Root of 1 by root of 1 plus 1 by n plus root of 1 minus 1 by n. As you know that this tends to 1 by 1 plus 0, 1, 1 minus 0, 1 is exactly 1 by 2. This is non-zero limit, non-zero finite limit. Therefore, Bn and summation Bn and summation An, both series will have the same nature. Therefore, as you know that this summation Bn, this is convergent by p-test. Once this is convergent, your given series is convergent, right? So this is what actually a very important, very important problem for root. When you're given a root problems, that the problems are, you can treat it as a very important problems. Suppose you're given a different problem based on the root. Suppose you're given this problem, summation n equals to 1 to infinity, n plus 1 whole power 1 by 3 minus n power 1 by 3. Here 1 by 3, 1 by 2 was 1 by 2 unte rationalization cheyandi, ikkada 1 by 3 undi. Therefore, what you do is that this is my n plus 1 whole power 1 by 3 minus n power 1 by 3. So what you do is that biggest power take common out. This is exactly given as 1 plus 1 by n whole power 1 by 3 minus 1, right? This is exactly given as, this can be rewritten as binomial expansion. So 1 plus 1 by 3 into 1 by n plus 1 by 3 C2 by 1 by n square dot minus 1. This plus 1 minus 1 cancelled out. Simplification, nothing else. So what you get? Here 1 by n common out. So n power 1 by 3 by n 1 by 3 plus 1 by 3 C2 1 by n square dot. This is a finite sum. It is stuck somewhere, right? 1 by 3 whole power something 1 by 3, right? So therefore this can be rewritten as what is this? Is exactly 1 minus 1 by 3. This sum is as it is, but this can be rewritten as what is this? 2 by 3, 1 by 3, 1 by 3 C2 n square 1 by n square plus dot, right? But the thing is, now you can choose this as a Bn. Now we can choose this as bn. So what is my bn? My bn is exactly 1 by 2 power n by 3. 1 by n 2 by 3. 1 by n power 2 by 3. Therefore, what is an by bn? An by bn is exactly this cancelled out, 1 by 3, 1 by 3 c2, 1 by n square dot, right? Therefore, as n tends to infinity, this tends to 1 by 3, because 1 by n tends, this tends to 0, this tends to 0, this tends to 0. So 1 by 3, this is non-zero limit, non-zero finite limit. Therefore, summation an, summation bn will have the same nature. Therefore, as you know that summation bn, what is summation bn? 2 by 3, this is convergent. Therefore, summation n is convergent. రైట్ ఓల్ రూట్ ఉన్నప్పుడు రేషనలైజేషన్ చేయండి. రూట్ 1/3 కాకుండా 2/3 ఇట్లా ఉన్నప్పుడు మాత్రం యూ కెన్ యూస్ బైనామియల్ ఎక్స్పెన్షన్. యూ కెన్ గెట్ ఆన్సర్ ఈజీలీ, రైట్? నెక్స్ట్, సపోజ్ యూ టేక్ దిస్. Suppose you can take 1 by n power alpha sine of n power beta. Test the convergence of this. Test the convergence of this. Right? So what is this exactly? You can apply the limit comparison test. Right? So this is my an. See, this is always positive. Already told you by Jordan's lemma, Jordan's inequality. This is positive. This is positive. Therefore, an is positive by Jordan's inequality. Right? So therefore, I can choose. See, మీకు ఇంతకుముందు చెప్పాను సైన్ సిరీస్ ఏంటుందో దాన్ని రాయండి యాజ్ ఇట్ ఈస్గా. లేకపోతే మీరు గెస్ చేసినా పర్వాలేదు, సైన్ సిరీస్ను రాసినా పర్వాలేదు, మీరు గెస్ చేసినా పర్వాలేదు. సో నేను ఇక్కడ గెస్ ఏం చేస్తున్నానంటే దిస్ కెన్ బి రీరిటన్ యాజ్, ఇక్కడ n పవర్ ఆల్ఫా కరెక్ట్గా అయ్యేటట్టు చూసుకోండి. యూ కెన్ చూస్ దిస్. మీరు చేసినా ఇదే వస్తుంది, సైన్ సిరీస్ ఎక్స్పాండ్ చేసినా ఇదే వస్తుంది. ఒకవేళ ఎక్స్పాండ్ చేయండి, మీకు అంత కన్ఫ్యూజ్ ఉంటే ఎక్స్పాండ్ చేయండి. Therefore, what is this? This x minus x cube by factorial 3 like this. So take n power beta common out, 1 minus n power beta whole square by factorial 3 dot. Now you can choose bn is, what is my bn? N power alpha plus 1 by n power alpha plus beta. So this also positive term series. Now look at the quotient. Is exactly what? 1 minus 1 by n power beta whole square by factorial 3, going on. This tends to 0 as n tends to infinity. Right? So therefore, an and bn will have the same nature. An and bn will have the same nature. Therefore, as you know that, what is this? So మనం చూడాల్సింది ఏంటమ్మా? Yeah. Therefore, an and bn will have the same nature. What is my bn? My bn is this. So this is convergent if and only if alpha plus beta is bigger than 1. This is divergent if and only if alpha plus beta less than or equals to 1. So therefore, your original series is convergent. Therefore, your original series is convergent if and only if alpha plus beta is bigger than 1. It is divergent if and only if alpha plus beta less than or equals to 1. Right? This is about limit comparison test. Next test is using limit comparison test. One of the important problem in Rodin. This is a problem in Rodin. Very important question. Suppose this is my positive term series. This is in Rodin. Positive term series. Right? In fact, this is convergent. So then summation an by 1 plus an is also convergent. By which test? Limit comparison test. By which test? Of course, this can be done by so many proofs. సో లిమిట్ కంపారిజన్ టెస్ట్ యూజ్ చేసుకున్నా పర్వాలేదు, మీ ఇష్టం. సో నేనేం చేస్తున్నానంటే సింపుల్ ఐడియా, I can choose, this is my sequence amount, this is my sequence. I can choose, I can take, this is my, suppose this is my capital AN. I can choose BN is AN. So this is positive on term series kada. So BN positive, AN also positive for every n. So both are positive term series. Therefore, look at the quotient. What is my quotient? AN by 1 plus AN by AN. Right? This is exactly what? 1 by 1 plus AN. As you know that this tends to 1 by 1 plus 0 because this is convergence series. Once this is convergence series, this nth term converges to 0 by nth term test. Therefore, 1 by 1 plus 0, this is equals to 1. This is non-zero limit. Therefore, AN, capital AN and capital BN will have the same nature. Capital AN, capital BN is convergent. What is capital BN? Your exactly given sequence. This is convergent series. Therefore, your capital AN by 1 plus AN, this is convergent by limit comparison test. So this problem is very, very important in routine test work exercise problem. మీకు ఎగ్జామ్లో వచ్చేటి రూటీన్ ఎక్సర్సైజ్ ప్రాబ్లమ్స్, రూటీన్ ఎక్సర్సైజ్ ఎగ్జాంపుల్ ప్రాబ్లమ్స్ వస్తాయి. ఎందుకంటే స్టాండర్డ్, మోర్ స్టాండర్డ్ అంటే ఆ ప్రాబ్లం వచ్చిన కదా అట్లాంటి మోడల్ వస్తుంది. రైట్, సపోజ్ యూ టేక్ దిస్ summation AN is positive term series, positive term convergence series. Therefore, this summation AN by 1 minus AN, whenever A not equals to 1 for every n, is also convergent. This is also the routine problem. Summation AN by 1 minus AN, this is also convergent. Right? Again, what test? The same test. Right? This is positive term series, positive term convergent series. Convergent series means AN positive and AN converges to 0. Once AN converges to 0, I don't know whether it is positive or not because it depends upon 1 minus AN value. Understand? Limit comparison test is applicable for only positive term series. AN positive, okay. What about 1 minus AN? This is positive whenever AN is less than 1. This is less than 0 whenever AN is bigger than 1. So therefore, it depends upon AN values. Now what I do is that I need to restrict AN. I need to restrict AN. Why? Because AN converges to 0. So after this stage, AN is less than 1 after N naught stage. Therefore, 1 minus AN is positive term series. 1 minus AN is positive after this stage. Therefore, your sequence, your given sequence is positive term series after N naught stage. Now you can apply your limit comparison test. This is my AN, you can say. I can define my BN is AN. This is also positive term series. Now look at the coefficient. Look at this quotient, not coefficient. Quotient. What is quotient? AN by 1 minus AN by AN. This is exactly AN and cancel because both are non-zero terms. We can cancel them out. So 1 minus AN. As you know that this tends to 1 minus 1 by 0. As you know that AN converges to 0 because you're given that series is convergent. So this is 1, this is non-zero limit. Therefore, AN and BN will have the same nature. BN is convergent series. What is my BN? Your given series. This is convergent series already you are given. By limit comparison test, AN by 1 minus 1 by N is also convergent. Right? So this is very, very important problem. Next. So this is CSR question. When do you say that for what values of A log n whenever n is equals to 2 to infinity? Of course, this is possible for n equals to 1 also. Right? So for what values of A? CSR question. The series is convergent. It is convergent. Right? So this is A power log n. This is exactly rewritten as, this can be rewritten as n log A. Right? Or else if you don't know this, what you do? You can take this as y. Now take logarithm on both sides. Log y. Therefore, this can be rewritten as log of n power log a is equals to log y. This tells you that y is equals to n power log a. So what is your y? Your given sequence. Your given nth term of the series a power log n is equals to n log a. Therefore, this can be rewritten as n power minus of minus log a. Therefore, this can be, see, n power some number undi. N power some number ఉందంటే మీరు గెస్ చేయాల్సింది ఏంటి? పీ టెస్ట్ అప్లై చేయాలి అని అర్థం చేసుకోవాలి. పీ టెస్ట్ అప్లై చేయాలంటే ఏం కావాలి? యువర్ n by 1 by n power p లా ఉండాలి. n power p కాదు, 1 by n power p లా ఉండాలి. n power నెంబర్ ఎప్పుడు ఇచ్చినా పీ టెస్ట్ మీకు గుర్తుకు రావాలి. ఈ పీ టెస్ట్ అప్లై చేయాలంటే 1 by n power p ఫామ్ ఉండాలి. 1 by n power p ఫామ్ ఎప్పుడు వస్తుంది? ఇది నెగిటివ్ కింది తీసుకొచ్చినప్పుడు. Therefore, this is exactly nothing but what? 1 by a. Now ఇప్పుడు ఏ ఫార్మాట్ ఉంది? 1 by n power p ఫార్మాట్ ఉంది. So this is convergent if and only if log of 1 by a is bigger than 1 by p test. But this is possible 1 by a is bigger than e. This is possible if and only a is less than 1 by a, right? So this is convergent if and only if this is true. This is divergent whenever this is less than or greater than or equals to 1 by e, right? 1 by a, this is less than or equals to 1. This is of course and this is divergent by p test. Log of 1 by a is less than or equals to 1. That means 1 by a less than or equals to a. That means a bigger than or equals to. So ఇది సిఎస్ఆర్ లో ఇంత ముందులో వచ్చిన క్వశ్చన్. ఓకే, నెక్స్ట్ క్వశ్చన్. టెస్ట్ ద కన్వర్జెన్స్ ఆఫ్ దిస్ x by 1 plus x square by 1 plus x cube, right? Dot. Whenever x is positive, it will become a positive term series, right? So how can you show that it is convergent or divergent? What values of x it is convergent? You're asked to compute that. When do you say that this is convergent? For what values of x it is convergent series? So for that, what I do is that look at your nth term. What is nth term? This can be rewritten as 1x square. So this is in GP. So this can be written as n minus 1, right? 1 plus x square, 1 plus x cube for n equals to, this is your nth term of the series, right? So now look at the nature. Already you're given x is positive, right? Already you're given xn is positive. So whenever x is positive, x power n also positive, right? X power n also positive. 1 plus x power n is always bigger than 1. Therefore 1 plus x power n, this is less than 1. Therefore what I require? X power n minus 1. Multiply with x power n minus 1. Because this is a positive term, therefore this can be rewritten as 1 plus x power n is less than x power n minus 1. So what is this exactly? This is nothing but what? So this is nothing but x power n minus 1 by 1 plus x power n is less than 1 by x whole power n. So by comparison test, this series is convergent if 1 by x is less than 1. 1 by x is less than 1. That is, x is bigger than 1. Right? So this series is convergent means what? By comparison test, your given series 1 plus x power n equals to 1 to infinity. This is convergent if x is bigger than 1. Right? What about x is less than 1? What about x is less than 1? You need to check it. X bigger than అయితే కంపారిజన్ టెస్ట్ యూజ్ చేయండి. ఎందుకంటే ఇక్కడ ఈక్వాలిటీ వచ్చింది కదా, ఈక్వాలిటీ వచ్చింది కాబట్టి ఎక్స్ బిగ్గర్ దెన్ అయితే కన్వర్జెంట్ అయితే, మరి ఎక్స్ లెస్ దెన్ అయినప్పుడు ఏమైంది చెప్పలేము. కాబట్టి మళ్ళీ దాన్ని సపరేట్గా చేయండి. right? X bigger than 1 అన్నప్పుడు what is that x bigger than 1? X less than 1 అన్నప్పుడు కన్వర్జెంట్ అయ్యింది. X bigger than 1 అన్నప్పుడు కన్వర్జెంట్. What is x less than 1? X less than 1 అన్నప్పుడు you know this is my sequence, nth term of the sequence, right? Now what you do is you can take common x power n. This is possible because you are given that x is positive. X is non-zero. In fact, x is positive. Right? What is this exactly? 1 by x, 1 plus 1 by x over n. Right? Therefore, this can be written as 1 by x, 1 plus 1 by x whole power n. Right? As you know that 1 by x is less than 1, x is less than 1. What is this? So, right Rashinama, therefore, x is bigger than 1 and convergent n. Right? So, therefore, yeah. So, this is nothing but what? X power n cancel. 1 by x, 1 plus 1 by x whole power n. Therefore, what you are going to get is 1 by x, 1 by x power n. Right? So, therefore, this exactly what? As n tends to infinity, this is 1 by x is bigger than 1. Therefore, this diverges to plus infinity. Therefore, this plus infinity. Therefore, what you get? This is 0. So, it tends to 0. So, this test is not applicable. Right? This is x power n minus. Look at again once again. This is x power n minus 1. Why 1 plus x power n. X power n minus 1 and x power n common 1 plus what you get 1 by x power n minus 1. This is nothing but 1 by x power n minus x 1 by x power n. ఒక పని చేయండి లేకపోతే సింపుల్ యాజ్ x power x is lies between 0 to 1 కదా, x is lies between 0 to 1 కదా. సో ఇది చేస్తే ఏమవుతుంది మనకు రావట్లేదు ఎందుకంటే ఇది 1 by x bigger than 1 అవుతుంది కదా. 1 by x bigger than 1 కాబట్టి this tends to infinity అవుతుంది. నాకు అది అవసరం లేదు. రైట్? సో ఏం చేయండి, ఇన్ఫినిటీ అవుతుంది కదా, దీన్ని మార్వండి. సో ఏం చేస్తారు, యూ కెన్ చూస్ bn is equals to x power n minus 1 తీసుకోండి సరిపోద్ది. సో therefore what you get, an by bn is exactly what? An by bn is equals to, so what you get? So what I get? An by bn is equals to 1 by 1 plus x power n. Right? X power n minus 1, x power n minus 1 cancel. Therefore, as n tends to infinity, x lies between 0 to 1 kabatti, this 1 by 1 plus x 1 plus 0, because as n tends to infinity, x power n tends to 0 is exactly 1. Your limit is non-zero limit. Therefore, this series and this corresponding series will have the same nature. Therefore, this series is nothing but x power n minus 1, n equals to 1 to infinity. But what is this exactly? Summation n equals to 1 to infinity, 1 by x whole power n. So this series is convergent if 1 by x is less than 1. Therefore, this x is bigger than 1. Right? So this series is divergent if 1 by x is bigger than or equals to 1. Therefore, this is divergent x less than or equals to. This is if and only. ఎందుకు? This is geometry, ఇది limit comparison test కదా, geometric series. So this series is divergent if and only if x is less than or equals to 1. This series is convergent whenever x is bigger than 1. Therefore, what you get? You get that this series, your given series, మనకు bn కాదు కావాల్సింది an. This series is convergent if and only x is big. ఇక్కడ కూడా అదే వచ్చింది మనకి. Right? This series is divergent if and only x is less than or equals to 1. Right? X is positive, you are given. So this is convergent whenever x is bigger than 1. This is divergent whenever x lies between 0 to 1 including 1. Right? So next is D'Alembert test. Next is what? D'Alembert test. So D'Alembert test means you are given a positive term series of real numbers right. Now what I do, compute this limit. This is possible because we are working with positive term series. This is meaningful sequence. The limit, we can talk about the limit of the quotient because we are talking about positive term series. So compute this limit. If the limit is L, if the limit is less than 1, your series is convergent. If the limit is bigger than 1, your series is divergent. But this is a weak test. This is divergent. If L equals to 1, test fail. Means no conclusion. So example, suppose you take 1 by n, a equals to 1 by n. What is 1 by n? Summation n equals to 1 to infinity. What is this? This satisfy your condition. Yes or no? An plus 1 by an. What is n plus 1 by n? An plus 1 means 1 by n plus 1 into an. An is nothing but what? 1 by n. That means